And now, the derivatives of trig functions. Just trying to mix it up. So, we've talked about the derivative rules. Now we're going to talk about the derivative of particular functions. And we know all about polynomial functions because they are dictated by the power rule. But the question then becomes, what are the derivative of the trig functions? In other words, how do you find the derivative of sine x? And in order to do it with the limit definition of the derivative, you have to understand trigonometric limits, which we are not going to get into. So the other way of looking at it is by looking at the graph of sine x. So we're going to go and look at that for a moment. So here's sine x, and generally these are in radians. So this is really technically right about here is pi over 2, right? There's pi, 3.14, and then, there's your 3 pi over 2 kind of down here. And what we're going to do is we're going to try to figure out what the slope of the tangent line is. There's negative pi, just so you have a sort of a context of where we're at. Not quite straight, but that's negative pi over 2, and so on. Okay, so what I want you to notice is that right here, I'm just going to switch my pen. The slope right there is flat. So the slope is 0 there. The slope is 0 here. The slope is 0 is a flat tangent line. Slope is 0 there. And here again, the slope is 0. And then if we look at the slope here, it's negative, right? It gets progressively steeper until it gets to here, and then it starts to slide back to being flat until it gets to here. So essentially what it does is it's going down, it's negative and going down until it gets to here. That's the peak of where it's going to go, and it's about -1 there, because if you sort of extend this line, minus 3.5 to minus 2.5, one step in the x takes you down 1 in the y, but there are 2 steps, I guess, if you're going by 0.5. But the slope there is basically the line y equals minus x, and then it goes down to 0, and then it starts to go positive as we sort of draw tangent lines up here, and it gets bent until it gets to here, this spot here, and then it starts to slow down again, right? So you still have a tangent until it flattens out, and it's going to repeat the process over here. So it kind of goes down until it gets down to -1, that slope, and then it sort of stops and starts to get less negative again until it gets to 0. So you essentially get a graph that looks like this. I'm going to try to connect these dots. And if you look at that, hopefully you recognize that that graph is the graph of y equals cosine x. So just from looking at an analysis of the graph, you can get that conclusion that if our function, if f of x is sine x, then f prime of x is cosine x. So what we're saying is the derivative of sine x is cosine x. Okay? Then we're going to try to find the derivative of cosine x. So what we're going to do is we're going to write cosine x as something in terms of sine x. So hopefully you remember your double angle identities, but that's sine of pi over 2 cosine of x minus cosine of pi over 2 sine x, which gives you 1 multiplied by cosine x minus 0 times sine x, which is just cosine x. So what I'm saying is cosine x can be written like that, sine of pi over 2 minus x, and this is why. What that allows us to do then is find the derivative of this. We know the derivative of sine is cosine of this, and then this is really a chain rule. We have to take the derivative of that, so we put in times -1. Okay? Now this, we write it out again, your double angle identities. It's cosine pi over 2 cosine x plus sine of pi over 2 sine x. And so this becomes 0 times cosine x plus 1 multiplied by sine x. And so it just becomes sine x. Okay? And so the end result is that the derivative of cosine x is minus sine x. So those are our two trig derivatives, our two main ones, sine and cosine, and we can use them then to find the derivative. So we're going to follow all the rules we used before. So the chain rule and product rule and all those things still apply. But now we have trig functions involved. And so we have y equals sine of 3x. The derivative of sine is cosine. Actually, let me do this. Let's just get rid of all this and we'll do them together. So sine 3x, we just go y prime equals, and then we start with the sine. So we're going to take the derivative of sine as cosine. And then we multiply it by the derivative of the 3x. The derivative of 3x is 3. The chain rule. So there's our derivative. This guy, same idea. The derivative of sine is cosine of x plus 2. And then we take the derivative of x plus 2, it's just 1. Down here, we have a power first, right? We have sine cubed, so we do 3 sine squared. Then we multiply by the derivative of sine, which is cosine of whatever it happens to be. Then we multiply by the derivative of what's inside the sine and cosine in this case. And that derivative is 2x plus 3. So there's our derivative of the whole thing. And that's how you do trig derivatives. You just follow the same rules, sine, cosine, just sort of get added in as functions, all right? So here's another one. This one's a product rule. So you have x squared, and then you have cosine 2x. So we're going to sort of look at this as one function, and this is the other function. So y prime becomes the first function, x squared, multiplied by the derivative of this function. The derivative of cosine is minus sine. And then we multiply by the derivative of the 2x, which is 2. Then it's plus the second function, which is cosine of 2x, multiplied by the derivative of the first, which is 2x. Okay, so this is, again, this is f of x. This whole thing here is g prime. And then this is g of x multiplied by f prime. Okay, so that's how you do the derivative with trig functions in them. And you can find the equation of the line the same way. We're not going to bother with that right now, but that's trig derivatives. So we're going to talk about the other ones in another video, but that's sine and cosine.